This is page 4 of the network notes, and so we're going to talk about the transmission control protocol, TCP. So TCP and IP actually used to be one protocol. I would say the original protocols for the internet, and then they got separated into two. It is an end-to-end protocol, or host-to-host protocol, unlike IP, which is node-to-node or machine-to-machine, router-to-router, or router-to host, whatever. What it does is it creates a virtual circuit between hosts, and this is analogous to the old telephone systems where you pick up your receiver, talk to an operator and tell them who you wanted to call where, and they would use patch cords to route your call to probably another switchboard or to a local telephone. And so once your call was set up, then you could start talking. So with TCP, it establishes this end-to-end connection, and then you can just start firing data back and forth. And it is full duplex, so data can be traveling in both directions at the same time. It uses ACKs, or acknowledgements, and these can be part of data segments being sent to the other end, or they can be their own segment being sent if there's no data to send. So ACKs and segment numbers are used. I'll put an S after ACK. So ACKs and segment numbers ensure two things: that all data is received and that it is in order. It also uses checksums, which ensure the data integrity. So you'll learn about checksums in Mechatronics 325, I believe, and they use usually modulus arithmetic where overflows are dropped, and they can detect up to a certain number of bit errors. If your message is really badly scrambled, the checksum could potentially actually agree and say it's alright when it's not, but it's going to be a very rare occurrence. And so the data is treated as a continuous stream of bytes. So that's how it appears to the application layer, that it's either sending a continuous stream of bytes or it's receiving a continuous stream of bytes, and it's up to the application layer to figure out how to break that up and use those bytes. And this is done in segments, and when it sets up the connection, it determines what the maximum segment size is, and that's going to depend on the operating system of both hosts. So the ends of the circuit are called sockets. So when you're doing internet programming, it's called socket programming. so which are specified by the IP address and port number. And we haven't talked about ports yet. So if you think of the IP address as being like a building, the port number might be like an apartment number in that building. Okay, so let's just talk about ports a little bit. Ports 0 to 1023 are considered to be well-known port numbers, so these are reserved for certain protocols, and so you shouldn't be borrowing them for different protocols. So examples of these are port 20 is reserved for FTP, which is the file transfer protocol. I don't see FTP in use much these days, but it is still out there. Port 22 is for SSH, which is the secure shell. Back when I started doing stuff on the internet, we were using Telnet, and all your communication was clear text, so anybody that intercepted or sniffed one of your packets on the internet would be able to read what you're sending. So SSH uses encryption to prevent that from happening. Port 80 is reserved for the hypertext transfer protocol, and we've got 143 is used for IMAP, which is the Internet Message Access Protocol, often used to access your email. Port 443 is for the secure version of HTTP, so it's HTTPS, so secure HTTP. So if you're setting up a server that's going to use HTTPS, which is often a good idea, depending on what you're serving, you use the secure socket layer SSL to encrypt the data. And the last one that I'll show you is 587, which is the simple mail transfer protocol. So you can look up these port numbers, and ones that are above 1023 you can use as you wish for your applications. They're 16-bit, so they go up to 64K.